Perhaps you've seen maps like these on the news when drought is being reported and wondered what the different colors actually mean. They are categories of drought that are set by the U.S. Drought Monitor. These maps have been produced every week since 1999, striving to accurately depict drought severity over the entire country. In this animation, we will break down the categories, which includes D0, representing drought watch, and ranges from D1 to D4, with D4 being the most severe. At first look, drought seems simple enough. Less water than we need or are accustomed to at a particular place and time of year. But as we dig a little deeper, it gets more complicated. The severity of drought is based on factors such as precipitation, soil moisture, stream flow, groundwater and reservoir levels, on-the-ground reports, agricultural health, temperature, water demand, and specific geography. In some regions, snowpack becomes a critical factor, not only to the surrounding area, but to other downstream regions as well. All elements need to be considered when forming the drought classification. Briefly, let's look at the different classes and what they mean. D0 indicates abnormally dry conditions. You might expect to see the slowing of plant growth if you were heading into a time of drought, or fields not quite recovered if you were coming out of more extreme conditions. D1 would indicate moderate drought conditions. You may notice lower stream, lake, and well levels and perhaps some damage to crops. There may be requests to curb water usage from local authorities. D2 levels indicate severe drought. Now those requests to curb water would likely move into actual water restrictions. You could expect water shortages with a good chance of damaged crops and pastures. D3 levels would be considered extreme drought. Water shortages and restrictions would be widespread and major crop and pasture losses would be imminent. D4 is classified as exceptional drought. At this point, you could expect depleting reservoirs and aquifers. Water shortages would climb to emergency levels, and you could expect lower empty streams and lakes, affecting not only agriculture, but fish and wildlife as well. Now that we have an overview of the categories, let's add some statistics to further our understanding. As you see, each category has a percentile range associated with it. For example, D1 drought conditions is in the 11th to 20th percentile. Looking at it another way, if we looked at 100 years of precipitation data and lined up the values in order from lowest to highest, we would then need to see a value that falls somewhere between the 11th and 20th on the list in order for it to be considered D1. For D3 drought conditions, or 3rd to 5th percentile, the value would need to fall between the 3rd and 5th lowest on record. We can describe each category this way by how often we would expect to see these conditions. 1 out of every 3 years for D0, all the way to 1 out of every 50 years for D4. However, just because a 100-year drought is expected once in 100 years, doesn't mean you'll get that drought every 100 years like clockwork. It's possible to have 2 100-year droughts in a very short time span, or not to see one for over 200 years. Let's look at this example of 120 years of annual precipitation values from western Colorado. As you can see, D4 conditions only occurred 2 to 3 times over this 120-year period, but 2 of them happened within about 25 years of each other. If droughts were to become more frequent and more severe, those observations would be added to the climate record, which would then change what we may expect. The severity of drought can increase over time as factors contributing to drought compound. That's why these statistics are valuable. They let us know what to expect, or can at least show us how often these events may occur. Since forecasts of developing drought have not yet been perfected, an accurate depiction of current conditions and their trends, along with a keen awareness of local climate conditions, can serve as an effective drought early warning system for resource managers and decision makers. Here's something worth considering. Different classes of drought mean different things in different places, and the effects can be drastically different as well. A D3 extreme drought in the Nevada desert looks very different from a D3 extreme drought in the middle of Kansas, affecting tourism in one place while agricultural in the others, for instance. It's also important to point out that individual factors may vary greatly throughout a region, which makes assigning the drought category a challenging process. Take the Upper Colorado River Basin as an example. It may show snowpack at D3 levels, the streams at D0, and the reservoirs and aquifers may not be within drought range at all. Elevation may cause a huge disparity in moisture, such as high snowpack in the upper mountains, but very dry valleys. Add in more variables such as natural forests, grasslands, and human-managed landscapes all responding to drought quite differently, Then you start to see why such a balanced and integrated approach is needed when establishing drought categories. This is a concept called a convergence of evidence approach. These maps are as detailed as reasonably possible down to about the single county level. The more quality, on-the-ground reports we receive from you, the better the resolution of these maps get. And as you see, the quality of these maps have been improving over time. However, we can't yet fully depict the remarkable local variability of precipitation, especially from localized thunderstorms. In the end, these quantitative values must be judged by experts and locals in the area to provide a classification based on a convergence of evidence, taking in additional considerations such as the time of year and overall climate of the area. That's why each week, all of the information is gathered, discussed, and assessed to get an overall picture for any one region on what drought category you may be in.